Okay, welcome everybody. Glad you could make it to the graveyard slot this afternoon. I really appreciate that you are willing to come to my talk here at 6:15 and even sitting through, I hope, until 7 o'clock this evening. So thank you so much for coming. My talk will be about architecting systems for continuous delivery. And before I will get started with my story, I first want to ask you a simple question. Who of you think that it's good to have duplicate code in your code base? Who thinks that's a great idea? Let me rephrase the question. Can I ask, who thinks this is a very bad idea? Can you please stand up if you think this is a bad idea? Or should I rephrase it then? Sit down? Okay, so, because what you see is that if I ask this question, if duplicate code is a good thing, and you can sit down by the way, otherwise it will be a very long ride. If I ask this question when I go around and do my consulting gigs, I get like 99% of the time constantly, duplicate code is bad. But the question is, why do we think that duplicate code is a bad thing? That's because we have been programmed as of our, I would say, programming childhood, that that's a bad thing. But do we still know why that's the case? I think that if I would ask that question, and unfortunately the room is a little bit too big, so I will answer the question myself this time, but the answer that I get is that it's because when we have a bug in the code, we have a duplicate bug in our code base, so how would I be able to fix the code in multiple places? And that was true when we were coding in punch cards, because it's very hard to detect if you have duplicate punch cards and you need to figure out where that code is. But if we look today at our code base in a Git repository, in, for example, VSTS or in any other environment, we have the ability to search for duplicates like in seconds. So why is duplicate code then still a bad thing? Because the opposite of duplicate code is that we are all of a sudden creating some central entity that everybody takes a dependency on. So what I'm trading off here is the fact that I might have a bug and it's hard to figure out where I need to fix the code twice, or I am going to create coupling in my system because multiple things will take a dependency on that same code base. Now, why would you say, go about and ask this question when you start with a session on continuous delivery? Well, it has to do with the fact that we as human beings are trying to strive for insanity all the time. Because what we're trying to do is do the exact same thing and expect different results. And before I start with my talk, I want to make perfectly clear that the stuff that I will be talking about this afternoon might come in and you say, I'm not sure what I think about that. Because you've been programmed all the time to do it in a certain way. Who of you have development, test, acceptance, and then production? Who has these different environments in their organization? Yeah. Do you know why we have that today? Because CPU, compute, hardware was always very expensive. And we needed to ask for new hardware and need a budget approval and all that other stuff to make new test systems that we could test our code. But nowadays we have computer-defined, systems that we define in software. So it's software-defined compute, software-defined infrastructure, and all of a sudden I can just click on a button and I have my compute resources available using cloud techniques, for example. And all of a sudden I only use it for a couple of hours and then discard it, and it's not costing me anything. So when we go through this deck today, I would like you to rethink the way you've been thinking as of now. Because we need to do things a different way to get different results. Now the agenda for this afternoon is that I want to share with you some challenges that we have if we want to do continuous delivery. We want to continuously deliver software to a production environment. And for this I will have a look at how we can ship in smallable units. I will look at how we can decrease the coupling between systems, and I will look at how we can do zero downtime deployments and new ways of thinking around releasing your software and testing your software, and then I have some homework that you can read up on later. So if you look at the architectural changes of continuous delivery, then we have the software that we have today as one cohesive set of software that we built. And what we need to do is we need to ship it all in once. We need to bring it to production all in once. And what we have is that we have these code bases in our version control system where we have these long-lived branches and where we need to merge our code base to some certain branch before we can ship it. And what you see is that the test process probably will take you a couple of weeks or months to get done. You probably have a test department. So who of you has a test department still today? Nobody dares to raise their hands, or I can't see, but yeah. So what you see is that it takes a long time to do our testing, and we all love those weekends that we can come to the office and install new software, right? That's the world we've been living in as today. Now what I want to do is have a look at how we can break these things down and how we can ship multiple times a day if we need to. Now, be careful there, that's not the goal. The goal is to deliver your software every moment you need it. That might be every week or every 2 weeks, but the idea is that you can deliver more or less on any day or any moment of the day that you want. So if you look at smaller shippable units, what is the things that you need to look at? Well, you need to look at the current architecture of your system. You might at the moment have something like a monolith. Well, we of course have nice different layers of our software. We have a database, and that's the way we crafted our software for the past decades. Then came along software service orientation. So we all of a sudden started to do SOA. And this promised us that we had more like the independent services, and that when we wanted to create a change, that we only could ship a different service and we would be good. But the problem with this service-oriented architecture has been multiple things. First of all, we thought that we could decouple our system by all of a sudden taking a dependency on XML schemas or schemas in general. But that's nothing else than taking a dependency on a C# class, a Java class, or anything else, because it's still a very hard, strong dependency on some XML schema that might be in there. And if I need a change in this system, on the UI, in the database, and throughout the messaging, I still need to come in the weekend and need to coordinate a release across multiple teams that are responsible for different things. And it's very logical that we've been organizing ourselves around these systems. So we have now teams that are responsible for our enterprise service bus, or perhaps better known as enterprise spaghetti bus. So we have teams that are working on the UI. We have teams that are working on our SAP system, our data warehousing system, our systems of record. And they are very focused on that because if you're doing a master's in business, for example, you get learned that you can do something like operational excellence, and it means that people do the same stuff. You put them in the same room, and they keep repeating the same work all over again because they become more efficient in doing so. But the problem that we have is that our customers are coming in from the top and want to have an experience completely through our whole stack of groups and teams and people that we have organized around a certain set of pieces of software. Now, of course, the alternative might be that we have a microservices architecture. But be careful here, because when we are going to talk about microservices as a solution, we need to be very careful that we all know perhaps the hype cycle. And what we're looking at here is that we are somewhere on the trajectory up at the moment if it comes to microservices. There are only few companies that have real experience in building these systems in a good way. So the things that I'm going to share with you is part of the journey that we make with certain customers if it comes to microservices, and the things that you can leverage from that. But believe me, boy oh boy, there are downsides on using a microservices architecture. Now, question for you is, if you look at this website, and I could have taken any shopping website or any more or less software as a service product that might be out there, the question is, what or who or which service is responsible for running this website? Now, if you look at this website, and if you look at Amazon specifically, then none specific service is responsible for only this complete experience. What they've done is they said, well, we need to compose our system because when we need to update something in our catalog, we can then show something different still in the UI. If we don't have the recommendation engine up for 24/7, we might not show recommendations, but we can still sell stuff. So the whole system has been designed around the notion of availability. And then when we're talking about availability, that means that we are more up all the time, and we can deliver the features more faster into productions, but there's always a trade-off. And the trade-off that you see if you're going to use systems that are individually sliced is that they become completely responsible for their own slices, but with that, there's a price to pay as well if it comes to consistency. So everybody can see that if you would go from this layered architecture, going to this mesh of microservices must be the best thing that you can do since sliced bread, right? The thing is that we're trading something in that was built and designed around a set of constraints. And the same goes that we're now building these systems which are microservices focused, but we build them on new types of constraints. For example, the constraint that we're trying to optimize around is that we want to ship a product 30 times a day. We want to deliver software to production multiple times a day. That's the constraint that we set to build this type of architecture. So it's important to see that we always strive for and optimize around a certain set of constraints. In my opinion, doing architecture is nothing more than coming up with a certain set of design principles based on a set of constraints that we know that we have. The constraints that we had in the past is that compute was very expensive, that compute was hard to get by, and that we had infrastructure and we had a lot of people running around to get a network done. But nowadays, it's just a script that we run in some kind of form of a cloud or a private cloud, using Azure Stack, for example. And all of a sudden, this stuff comes to life just by a flip of a switch. So there are different constraints that can now enable us into new architectural design patterns. Now, the question is, how can I decouple our systems? And the way we can do so is looking at the notion of cohesion. Now, if you look at a system based on the principles of cohesion, then you can look at it and say, okay, so if I have a certain set of components in my software, what is the way they work together? And the worst type of system you can build, and I probably hope you can imagine, is something that is cohesive at a random moment in time. Because then we're building random systems. Some people might argue that looks like AI, but that's not the way we would like to build our systems, right? We want to have some deterministic pieces in there. Now, the other way of looking at things is logical cohesion. So things are gathered together as one logical part. So let's, for example, say everything that has to do with messaging, or everything that has to do with data warehousing, or everything that has to do with user interfaces. So that concept is based on the notion of logical cohesion. Now, you can look at other types of cohesion. You have something like temporal cohesion, which is just, it's cohesive at a certain point of execution. We have procedural cohesion, where we have a set of execution sequences that are fixed and stitched together. We have informational cohesion. It's cohesive on the data side of things. And we have the notion of sequential cohesion, where one is more or less the producer and the other is the consumer of the stuff that's been done. Finally, we come to the set of cohesion, which we call functional cohesion. And functional cohesion means that it's cohesive in a sense that it all attributes or contributes to one single task in life that it's good at. Now, if we look at cohesion logically, then we are back in service orientation. Because there we had these layers that are grouped together based on the logical fact that it's messaging, or it's UI, or it's something else. If we look at microservices, then all of a sudden we're going to look at functional cohesion. We're going to create these vertical slices instead of the horizontal slices that we have. And I'm not sure, who of you were in the session with Martin Woodward previous to this? A couple. So there you have heard that Microsoft creates even teams that are completely responsible for one autonomous business function, you might say, and a specific feature they need to deliver from front end to back end, and even need to do the DevOps part where they get calls at 3 a.m. in the morning if they have a live site incident. So you create teams that are responsible for the full slice and the full functionality, and we have some way of meshing it up in a UI so that everybody sees it as one cohesive product that you buy. So what we are doing is we are changing our way of organizing ourselves. The organization itself is not organized around a BizTalk server or some messaging infrastructure that you have, and you don't only have the UI guys in one team. No, the idea is that we're going to mix and mingle. We're going to create these teams that are completely responsible for the whole vertical slice that we're trying to build. So what we're trying to do is we're going to build features, we're going to build different, more or less complete stacks that operate as one functionality to the end user, and based on that, we can mesh that together as one full-fledged product. Now, how do you define these vertical slices is then the big question. Because it's great that we want to cut things up, but cutting things up means that we probably in our current system have a lot of communication going on. And the problem is that we all of a sudden have the problem that we have what we call coupling. Remember the class that I talked about before? The trade-off that we're doing, redundant code versus getting coupling and doing it in one class. So what you see here is that we're going to try to find what we call autonomous business capabilities. And an autonomous business capability is good in one thing and one thing only. And we're going to create a microservice for that, and the only sole purpose in life is doing that particular thing in life. And if we don't need it anymore, we just throw it away, and we might replace it with something else and something new that can be done in a different way. Now, if you look at coupling, then we have the notion of no coupling. Think of the redundant code that I talked about in two different classes, and yeah, it's just completely unrelated. It is not coupled at all. So if one component or one piece of software fails, the other is not affected in one way, shape, or form. Now, the other thing is that you can have low coupling. And low coupling means that if one system will go down or one vertical slice will go down, I will be impacted on a minimal level. We still might call it a life-side incident because it's one particular capability that we cannot serve to our customer anymore. Think of a recommendation engine that might be out of service at that point in time, but it does not affect the complete experience and everything is being teared down. And then we have the notion of high coupling, and high coupling is what we've been doing all along. High coupling is systems where just the smallest piece in my complete stack of software fails, everything fails and falls down. So if you look at the current architecture of your system, you might have access to a database, and what happens if the database is not available? Probably you will crash and burn. Because that's the way we've been developing these systems, but now moving to the cloud and other types of hardware and infrastructure, we need to cater for the fact that some stuff might not be available intermittently or for a longer period of time. And we're striving to build these vertical slices that have low or no coupling, and that's the way we define our microservices. Now then the big question comes, so let's say that I defined this notion of a sales context. So we're doing some kind of business capability in the context of sales. And we're doing something similar also based on, for example, a customer or some user that you have in your system, and that's in the context of support. Now, support has different rules around the way that software works than the sales organization does. But we all talk about this identity, this user, this one person that is shopping for us, or whatever you want to call it. Now, the question is, how are we going to cope with the data? Because in the past, what we did is we came up with this notion of all these teams coming together. Yeah, if I look at a customer, then he has at least a first name, a last name, and perhaps a middle name. And then the other part of the organization is, yeah, but we need to know if he's someone that has a college degree or not. So he has, in the Netherlands, then something like IR or ING before its name, because that means that we need to treat them differently. They all want to, of course, have discounts and those kind of things. So all of a sudden, we have a different business need. Now, the question is, how do you cope with this if you're going to do these vertical slices and there may be no coupling? The idea is that we don't go and sit together in long meetings to decide on which attributes are part of our customer, but what we're saying is, in my bounded context, in my universe, in my single view of the world, I only need these attributes and I'm done with that. Oh, but in the other side of the world, we need these attributes, and we just live with that. And the only thing we decide on is how we can correlate the two together. Just one single identifier that we need to come up with. Interestingly enough, by the way, if you try to do it this way, you still might have a long meeting if that needs to be a GUID, a string, or something else. But nevertheless, it's something that should be debatable in fewer time to get done, and build your data around that. Now, if you look at the way we can communicate between services, then in the past, the way we did it is always with this notion of a request-reply pattern. What we've done is we said, okay, I need something from someone else. I will get that information, and then I go to something else, and I get that information, and then I can do something else. So it's this whole cycle of request-response going on and on and on and on. And what happened if one request failed? The whole operation more or less failed. Because we couldn't go further. Yeah, we might retry it a couple of times, but we are stuck at that point in time. And the problem is that I take a way harder coupling because it's request-response. That thing needs to be in the air the moment I am asking a question. Now, the alternative way of looking at this type of communication is that, what if we don't do request-response anymore, but we're going to work based on an eventing system? We're going to publish events that something has happened, and I couldn't care less what someone else is doing with that data. It's not my responsibility. The only thing that I'm going to tell the world is, there is an order placed. Have fun. And then we have another service that might do something with shipping, who might say, perhaps I need to ship an order. And it will respond to the fact that an order was placed, and based on that it can then eventually ship stuff. Now, the interesting part about this is that, first of all, you can have different latencies between the calls that are being done, or the data that is required. And the thing that we have, there's no central logic that is coordinating everything. It's more like all these events happen, and then stuff happens after that. By the way, that's the way we live our lives, right? I mean, events happen, and then we respond to it, and then, yeah, we might end up somewhere. It's more natural to the way we do our living, but it's harder to coordinate. It's also a challenge when this system crashes to get to a certain state that we all agree that this data is good again. But the big benefit here is that if one of the other services that is receiving my events is not available at a point in time, I can just continue my work, and I'm not in any way, shape, or form impacted by that. Well, you might say, but what happens if the customer updated its address and now we're shipping to something that we don't have the address from yet? Well, that's a business decision. Are you going to ship it to the wrong address, or are you going to wait with shipping every day after a certain time, and that we know that the time has been elapsed for, let's say, an hour, and we know that we are eventually consistent within the hour, because that might be a constraint that we have on our eventing system. Now, the important part here is that we don't want to fall in the same pitfall as we've done in the past. We don't want to all of a sudden become dependent on this intelligent routing service or an intelligent bus, this errand spaghetti bus, right? So the only thing that we're going to do is we're going to communicate all these events over simple dumb pipes, and the thing that we're going to do is we're going to build smart endpoints. So we know that the moment I get the data, I can do something with it, but how it got there is not your problem. Now, things that you need to look at if you build these event-based systems is, of course, systems that are using queuing, for example. So think of Azure Queues, MSMQ, RabbitMQ, WebSphere think of Service Bus, Azure Service Bus, and try to do it in a language-neutral way, so using protobufers or Apache Thrift, those kind of things. One thing that's important if you have this eventing mechanism is that you need a way for a service when it comes to life again, that you can ask, I would like to have a replay of events from this moment that I know that I was still alive. Because then you can replay the events and become eventually consistent again. Okay? Now, for those you have different queuing systems, for example, Kafka has a very nice one where you can just ask it to replay all the events after a certain point in time or a pointer that you have. Now the big question here is that building a system that is this vertical set of slices, has its own data, and can live on its own, is that the way you want to build your systems? Remember again the hype cycle that I showed you. And the thing is that if you build such a system, it's way more complex than that you've been doing today. So there's a premium to using microservices. The trade-off is that every service on its own is small. It's good to maintain it that way. It's small in terms that we ship small packets. And we can ship any time of day if we look at some of the other patterns that I want to show you. So it has a premium to get started with this. And as a good consultant, the only answer I can give you is, it depends. Okay? If it's for you, it depends. It's worth trying, it's worth looking at, but it's no guarantee that this would be the way for you to change your system. Now then the question comes, how do we do a zero downtime deployment? And for this to happen, we need to have this notion of the fact that something can go wrong the moment we are working in our system. That can be a short failure or a short timeout. And for this, we need to minimize the downtime by using, for example, other orchestrated kind of software that can be used to orchestrate the fact that something goes down and we need to bring it up again. And we don't want to manage that ourselves. So for this, you use, for example, cluster infrastructure like Kubernetes or Service Fabric or Docker Enterprise, DCOS, you name them. Okay, there are many out there that you can use. The fun thing is that all these cluster orchestrators have this notion of a zero downtime deployment. But that's not for free. Yes, it's one command, but it only means that they will drain the traffic on that one service, bring up a new service, traffic goes there, and then you can take it out of the nodes. That means that if you are a stateful service, you will have pain and suffering. And you don't get a zero downtime deployment, at least your customer will not experience that. Might be all good from an infrastructure perspective, but not from a customer engagement perspective. And for this, we need to build in certain patterns and certain ways of building our software to be resilient to failures and ensure that we are not stateful, at least, and not stateful in memory, I should say. Now, one of the patterns that we use a lot is, for example, the circuit breaker pattern. And the circuit breaker is there because sometimes you all of a sudden know that something that I try doesn't work. And if it doesn't work, what is then the idea that I can start hammering that SQL server, for example, that I really, really, really want a connection, but that thing is not available at that point in time. Now what happens is that when the thing comes up again, it gets hammered with connection requests at the same moment, and we have a name for that. That's called a denial of service attack on your SQL database, okay? So you need to be careful with that, so we need to have the ability that the moment we see that things are bad, we need to flip the circuit. The moment we have voltage going through our kits, we need to break the circuit, okay? That's the same thing here. When stuff goes bad in your software, you need to break the circuit and do something else. Either read from cache, write to a queue, all possible different implementations of what you want to achieve, but the basic path that you have is not available at that point in time. Now this goes hand in hand with what we call a retry pattern. Because you want to retry it, but you don't want to have a denial of service attack in your system. So for this, we have the gradual back-off pattern. We say, well, we are going to retry this, but first time not succeeded? Okay, I wait a bit. Second time not succeeded? Let me wait a little bit longer. Oh, the third time didn't, well, let's try in an hour or so. Because then we know for sure that we're not hammering that system all the time while it's already in pain and suffering because it's not up and running. Now the other thing that we would like to do is we would like to separate a thing that we've been learned and grown up with since day one, at least when I started in the software industry. Who of you have experienced these weekends where they need to come to the office all and we're going to install this software? Oh, you guys are very lucky. I've experienced those weekends multiple times. The fun part is always when I get to do something, but most of the time we're playing some card games because we're waiting on someone else to do something, okay? But the thing is, what you would like to do, and the thing that we've accustomed to, is that when we install our software, that's the moment we more or less give the features or the new software to the end user. Well, those things are two separate things, right? We just built a piece of new software, and we install the new software, but then the second part is I want to expose that to my end user. We can separate those concerns. And if we separate those concerns, there's one very nice thing going on. I do not have to call anybody to deploy something to production because they don't see that something new is in production. It's just the new software doing the stuff that it already did. But for this, we need some mechanisms in there to make that work. So one of the things that can help you with this is the notion of feature toggles. And a feature toggle is like on the contrary on what you're used to just create a branch, work in a branch for a long time, then merge it into your main line and then ship it. No, what we're doing is we're integrating in the main branch all the time, but what we do is we guard it with a feature toggle. Now a feature toggle sounds very cool. If you go back to the office tomorrow and say, I learned all about feature toggles, I need a raise. Probably you get it. But the thing is that a feature toggle is nothing more than an if statement, okay? So don't make it too fancy. It's just an if statement. If the toggle is on, then we're going to do something. If it's off, we don't touch it. This means we can ship code that does not work in production just by having a switch around it that hopefully nobody touches, of course, because otherwise you're toast. But the idea is that we can break up the notion of installation of our software, and then we have the notion of revealing a feature to our end users. Now, feature toggles are great, but you need to maintain them, okay? Feature toggles are just technical debt as long as they're in your software, and you need to clean them up the moment you don't need them anymore. By the way, I think that everybody uses feature toggles because we probably all have systems where you have this notion of authorization, where you reveal a feature based on permissions. That's nothing more than a feature toggle. Probably you won't want to clean them up. But the other stuff that you just have for release toggles, and that's the reason we have the notion of release toggles over there, those are the things that we need to clean up. And sometimes we have this notion of operational toggles. Those are in there as like a kill switch if something goes bad for operations so that they can revive server health at that point in time. It's like degraded capabilities that you have at a certain point in time. Now, one of the things that we're probably accustomed to is that we get this question, can we please refactor a piece of our code? Can we please get this component out of our system? We want to replace it with something else. And what we do often is that we go in, change the code, merge it back to main, and off we go. But there is a pattern for that. It's even described by Martin Fowler, which is called branch by abstraction. The idea is that first we have this code that goes into this what we call a flawed supply. It can be any component you would like to replace. The first step that you will do is you will extract the interfaces from that particular supplier that you're communicating with. Then you let the current code base implement that interface, and all of a sudden your client code will talk to the interface instead of the actual implementation. Something you should do anyway because it's a good practice. The next thing that you can do is then say, okay, so now every client code will be using the interface instead of the actual implementation. And from there on, I can then do a new implementation based on the same abstraction and start using that from one client. Now combine this with feature toggles, right? Combine this with feature toggles, guard it with feature toggles, and all of a sudden I can ship that constantly with no fear. Because if I screwed up on the new supplier part, I flip the switch and it's back to the old crap that I already had. This is a way of enabling you to do continuous delivery because you're delivering the software and you can do so without any fear because you can always revert back in production on what you had. The other great thing is that the moment you go to production, you can see what the impact of your new software is based on how your systems are doing. So I urge you to also build in telemetry the moment we're going to use this kind of stuff. Because then you can see who is using your software, who is, how are my servers doing? Am I still stable? Am I consuming more CPU cycles all of a sudden because I have this new implementation? And the final thing is that we need to look at deployment. We can deploy the software in different ways. The way we've been doing this is that we just build our software, ASP.NET, for example, or some WCF services, some GUI. And what we did is we just installed that with an installer on our bare hardware. But the thing is that today we also have the ability to stuff that in, for example, a container. And we can run that then in different configurations. The container is on itself something that we can ship and move around. And all of a sudden we don't need those different and complex environments anymore. And we can scale up also this one microservice just because that's the one that's taking all the capacity, and you don't have to scale up everything at once. Okay? So with different ways of hosting our services, and we can do it either on one host, or we can split it up and have one service per host because we just need the compute power to make it work. Now the final thing in deployment is that we've been used to installing our software to a machine that probably everybody knows. It probably has a name in your data center. You need to go to server XYZ, and if you're lucky, it's something with a number in there and something that's perhaps indicating which data center it is. Heaven forbid if you're still doing these goofy names like this is, let's say, Donald Duck, and this is, well, someone else, right? And you need to deploy to Donald Duck, and then that's our first stage. And then you go to Katrin, that's the second stage. Well, that's the stuff that we've done it in the past. But the thing is that we would like to make our software deployment and our infrastructure deployment as one. We're going to deploy our software always to new environments, new hardware. That hardware might be created by software, but still, we're doing that in one simple way. So the idea here is that we don't have this hardware laying around in specific configurations anymore, but the moment we need something, we just spin it up as we need it and tear it down when we're done. We call this an immutable infrastructure because we're never ever going to log into a server anymore and tweak something on the console. The only way we get that server into another state is just by rolling out a new instance of that thing based on scripts or based on containers if you want to make it easy. Now containers are something that has come to the Windows platform now as well. And it's a very, very powerful type of infrastructure as code that you have that you can just lay out and push to your different servers. The only thing you need is a couple of servers or virtual machines that can host containers. And what you're going to do is instead of creating an installable package and install it on every different machine, the way we are going to move it now is we're going to say, okay, we stuff it into a container, and that container will move around between different configurations that I might have of hardware or cluster configurations that we want to use. So the idea is that our continuous delivery pipeline, as we have it, starting at source control, building binaries, and then deploy to test, deploy to the other test environment, and then go to production. Now what we're going to do is we're going to take our sources, still build the binaries, then bake a container, and from that container on, we move it through our environment. And we can be guaranteed that in every environment, it will actually operate in the exact same way, because it's a complete container, and it has everything in there. Now tomorrow, my talk will be about this whole notion of this delivery pipeline. I'm going to talk how you're going to build your applications using containers and moving that throughout an environment so that you can then deploy it eventually to, for example, Azure Container Services cluster, or moving it to a Service Fabric cluster, for example. So then we have the notion of testing. And this is something where we need to rethink the way that we've been thinking in the past. Because the way we've been taught to do things is that we need to build as much unit tests as possible. Who's unit testing? Everybody, right? Who's really unit testing? Really, really unit testing? Not trying to see if the .NET framework can calculate values? Because that's the stuff that I see most of the time, that we're trying to see if we can set or get a property. Well, probably we can. That's something that the .NET framework takes care of. I make a little bit fun of that, but we've been really taught to do unit testing to lengths and extents, but the fact is that we just aren't capable of doing all these tests to get the reason for us to test is that we want to have confidence, can we go to production? But can we get the confidence by just using unit tests? No, we need integration tests as well, and we might need some manual intervention. So for this, in continuous delivery, we think about we need to automate everything. So let's say I have 200 tests that we do manually. I get so often the question, Marcel, can you come in and help us do test automation? I say, yeah, sure. And I'm coming in, and they say, well, we got these 200 UI tests that we need to do. Can we automate them? I said, nope, we're not going to do that. They said, why not? You were hired to do the automation here. I said, yeah, but I want to do it the right way, because doing 200 tests that are scripted out in Word documents all of a sudden in automation will not help you, because you still have a test cycle of perhaps days to get things done. And what is the actual confidence level you get if you have all these crappy tools around that don't work? Because Selenium might sound great, but it will break sometimes, and you don't know why it broke, and you run it again and it works again. We call it flaky tests. They're useless. So you need to rethink, how can we test this software in such a way that I get confidence? Now, you probably know this, right? There's no way or no place as production. And by the way, most people are testing in production anyway. But this has been done for ages with what we call A/B testing, for example. And isn't it possible to adopt certain types of patterns ourselves in the way we deploy our software? So we have a certain level of confidence based on the fast-run tests that are based on, for example, unit test frameworks, but we create this user group, and we treat them special. We give them a badge. We call them, for example, most valuable professionals. I earned the badge. It's cool, right? But what I'm doing is I'm testing the beta software of Microsoft. And who of you is doing the Insider program? You're a tester. Nothing more than that. And it's their program to test in production. And that's the way they get their confidence in can they ship it, yes or no. Now, testing in production is done, for example, in a very nice way where you say, well, first, don't impact all our users at once. Just start with, let's say, 1,000. For some companies, that might be all your users, but in this example, we just take 1,000. And then we have this feature. We deploy it to a production. We see how things are going. Remember, we have telemetry. We have feature switches to switch it off if things go bad. And then we say, well, this looks pretty good, pretty awesome. Let's go to segment B. And we have like 10,000 users. And then we go to the rest. And that's the way we gain confidence, just by letting our end users test our product. Well, you need telemetry in there to know if your user is actually liking your features and your new implementation, because otherwise you're better off implementing it a different way and not shipping it until the last skill unit. So choosing your skill units is very important, and you need to have telemetry built in to learn what is going on in your environment. Now, if you're doing this, we call this the notion of a canary release. Now, this comes from the mining industry because a canary has a very distinct feature. The feature is that it will drop dead earlier than a human being. Because they took it into the coal mines, and when there was toxic fumes, the canary would die, and the guys knew, we better run. Well, this is the moment that we flip the toggle back and say, ooh, that was not good. Let's try that again, and do a roll forward, because roll backwards is for chickens. Okay? Now, if you really want to become fancy, we're not doing canary releases anymore. We're going to do a dark lounge. And a dark lounge is nothing more than a canary without a head. Because we're leaving out the UI to the end user, so they don't know that you built something new. In the meanwhile, you're testing out if your system is stable, the data is flowing through your new features, and based on that stability, you can say, let's flip the switch, and the canary gets ahead. And that's the moment you expose the feature to the end user. So now what you've learned, and you probably earned a raise just by telling this in the office next week, is now you know how to do a canary release or a dark lounge. So to wrap things up, try to compose in smaller units. Microservices might be a way of doing it. Use circuit breaker patterns, retry mechanism, feature toggles, branch by abstraction. Ways to minimize the impact that you do when you do a deployment. When you deploy, you use preferably containers, but if you're not up to that game yet, then at least make sure that you automate your full deployment. And like Martin said in his previous session, there's nothing but something that is like a half automation. You automate it or you don't, but there's no halfway in between. Treat your infrastructure as cattle and not pets. So when a pet is sick, we bring it to the doctor. If cattle is sick, we shoot it through the head. That's the idea between cat versus paddle, right? We don't reuse the infrastructure anymore. And we need to rethink the ways we've been doing things, so testing in production, canary releases, and dark launches. Now, if you want to read more about this stuff, these are some of the books that you can read: Building Microservices, Domain-Driven Design, very important, from Eric Evans, Continuous Delivery by Jazz Humble, for example. And if you like, go to our booth. We have Expert Magazine there, where we talk a lot about all these kind of concepts and how you can implement them in practice. And with this, I would like to thank you for your time. My name is Marcel de Vries, CTO of Expert, and I hope you had a wonderful time, and hope to see you back tomorrow. Thank you.